All right. I think we've got everything going. I wonder, does this chat on? Yeah, I think it actually does. Would you look at that? What is up, everyone? Today in this midweek stream, it is good to see everyone. I mean, I guess I don't really see anybody, but I do see Saif is already in the chat. What's up, Saif? Awesome. Again, all the time about the community here, the international community. Well, messing it up, kind of throwing up all of the I guess trying the different days of the week. I think this is probably the first Wednesday stream I've done, but the last one, when did we have the last one? I'm not sure, but tried all sorts of different times, so have different spectrum of people being able to get on. It's good to see. It's good to see everyone that gets on these. Yeah, it's awesome. So if this is the first time you're on, my name is Jason Watts. I am a owner and founder of a little automation company out of the US in Alabama called Alpha Industrial Technologies. I live in the Atlanta area, and I've got about 25, yeah, somewhere around there, 24 years of experience in industrial automation and controls. Most of that is with Siemens, but we also do a lot with Ignition. If you've never heard of the Ignition SCADA platform, you are missing out on some awesome stuff. But I am not the gold certified integrator on that. That is my other business partner, Brandon. We've talked about Ignition on some of the other streams, and we plan on doing some more of that. But right now, we're talking about Siemens drives. Specifically today, one of the coolest and nerdiest products that I believe that Siemens drives portfolio offers. Yes. So yeah, Steve is talking about Ignition. So like I'm telling you, when Brandon first showed me about the Ignition platform, and because I'm like, oh, it's SCADA, what's there to do with it? You know, it's like HMI software. My goodness, some of the stuff that we've got going on, like with our batching and recipe systems and some of our agriculture systems, we have live like KPI and production statistics for some of our customers, throwing them up onto screens like out on the floor, so that real time the people on the plant floor can kind of just look up and see kind of what's going, where they're standing, and yeah, so. And that's just so one little example of how powerful the Ignition platform is we have an inventory management system that manages all of our spare parts and our supplies and everything in our shop in Alabama. And well, we were wanting to kind of get like up-to-date pricing, and I'd say we, it wasn't me, it was Brandon. Brandon is a stinking wizard on this thing, because he was actually able to go out and get pricing for stuff and bring it in. Ali Reza, I'm so glad you survived the New Year's evening. I was kind of worried about whether or not you would actually make it through the whole evening without going to sleep. On the last stream, Ali Reza was on celebrating the New Year in style as a true automation engineer, and he was yeah, he was up at like 4 o'clock in the morning his time, and you're more dedicated than I am, I'll put it that way. But yeah, so that Ignition system, the inventory management for the Ignition, or in Ignition, was able to actually go out, pull in pricing like off the web, log in, pull pricing off the web, bring it into Ignition, and then associate it with all of our bills of materials and all this stuff. It's crazy wizardry. It's really awesome. But yeah, so that's probably why you're not going to see a lot of like WinCC, SCADA, professional platforms type stuff on here, because I have used the WinCC 7.x. I think it was 7.1 when I got it. I think it's now like 7.6 or something. And then I've also used WinCC Professional and WinCC Runtime. And so those are kind of the different flavors of Siemens SCADA platform. I have used those, and I've done some pretty cool stuff with the WinCC 7.x, scripting, interfacing into databases, doing some kind of like data manipulation, but nothing as easy as Ignition is. But yeah, I mean, eventually I'm gonna get Brandon to kind of teach me the basics of Ignition and kind of do it live on stream so y'all can kind of learn this stuff. And so yeah, as people are coming in, and I've tried to like get my volume up on this mic, and it's an ever fight. I turn up the gain on the mic, it starts clipping. I turn up the gain in OBS Studio, it overloads and starts compressing. I don't know. One day we'll figure out the sound to where you're not having to like turn your TV or your phone or computer up. But yeah, welcome to the stream, everybody. Today, originally, and what we are going to be talking about is the active line module system for the S120. If you're joining in and this is the first time you've kind of taken part of this, if you have a question or something, just throw it into chat. If you're watching this on demand, just throw it into the comments. I try to tend to go back through and find your questions on the comments and try to answer them. A lot of times on these projects, it just takes asking a question to the right person that has experience in it. I have experience in most of the stuff that I work on, or especially in these streams. I try to not get out of my lane, but also at the same time, I'm not afraid to kind of work through stuff on the stream. We're going to be doing some cool stuff, starting off with the active line module. And kind of the first thing that you really kind of need to go through and do, as I get this pulled up, is really, what is the active line module? What in the world am I talking about? And so let's go over to what is the Sketchpad? But this is the PM21-4 catalog making an appearance again. We talked about motors last week, and a lot of the motors that we talked about are in this same catalog. The PM21-4 catalog is kind of the motion control catalog for S120s, higher performance motors, and those sorts of things, such as the 1PH8s, the 1FK7s, the 1FK6, or I guess the 1FT7s and the 1FK7s. All that stuff we talked about last week on the motor stream. Well, before we did a winder, we talked about doing a winder, and we built a winder from kind of scratch. And in it, I included an active line module. And I'm going to kind of run through kind of the advantages of the S120s and that sort of stuff, but I talk about it a little bit more than probably what I'm going to talk about there. So definitely check out the live stream that is talking about how to build a winder, because I definitely talk about this common DC bus setup and how to use the active line module. Specifically today, we're going to go through, talk about the benefits of an active line module, how to set it up in TIA Portal, how to program it, because there is a kind of some weird stuff that I've found through the years that, especially if you're in the US, it's a little bit difficult and not straightforward to get that set up. So we're going to go through those and kind of go from there. Eventually, I'll have chapters on this. Obviously, I can't put the chapters in on the live stream. But yeah, so if you're watching this on demand, you can jump to the different chapters, and yeah, hopefully you can do this. So what we have pulled up here is is the book size active line module. And you might say, what in the world is just an active line module or system in general? So in the little thumbnail, I guess I could pull up the thumbnail. I think I have yeah, let me pull up the thumbnail. So this guy here. So this is a common DC bus lineup. So see, you have the motor modules on the right, you have the line module in the middle, and the controller, in this case, a Simotion D platform. But this is a common DC bus lineup. What's up, Lucas from Sweden? Awesome. Welcome to the stream. Again, always love the international audience that Siemens brings. I'm just a redneck from Alabama, living in the big city of Atlanta. And so, yeah, I love seeing all the different countries and all the different kind of backgrounds of where you are in your automation physically and in your professionally. So we're talking about this S120 setup, and so in this picture here on the thumbnail, we have kind of just a standard S120 setup, and it is kind of like what we have here. I'll zoom in on this so I can kind of like point things out. But again, this is the PM21 catalog, and you can see here that we have behind my head, we have these different motor modules and then the concept is that you take and you rectify your three-phase input into a common DC bus, and then that common DC bus, instead of having AC to AC converters like a G120, you just have DC to AC converters, and that kind of gives you the ability to dump that power directly between modules without having to suffer for those extra switching losses. So that's what we're talking about today. The common DC bus lineup is not specific for the Siemens S120, but it's a very powerful if you have multiple axes of motion, or you're needing kind of higher performance motion, because you get regen and a lot of better load sharing just based out of that. Again, the load sharing and winder application live streams, I go into a lot of details about that. So Lucas is asking, Lucas, you're welcome to ask questions, and especially I will try to fit them in a way that makes sense, I guess. But you can always ask questions, and I always love to answer even off-topic questions. And so, honestly, I think last week that was probably about an hour of the entire stream was me just randomly talking about off-topic things. So, oh yeah, so Lucas asked. So Lucas asked if we could possibly make a video about the G120, G120C converter, and how to design a control block for it, maybe with the Telegram 352 or something. So I want to say that I have talked about, I have a live stream on this. Let me look over real quick at my content on this, because I believe we may have even talked about that on a live stream. I have quite a bit of content of how to control G120s and S120s using technology objects, and on I want to say drive load sharing, possibly. In-out explanations. I know that we talked about that there. So I definitely can go through and set up a specific one, but I will send a link that you might want to check out, because I want to say we talked about G120s in this video. I'm copying that link over in the chat. So after this stream, of course, I mean, feel free to check out that, because I definitely talk about setting up G120s in order to pass information back and forth. And I'm pretty sure I use a 352 telegram. In the agriculture projects that I use, we mainly use G120s, and in those we use 352 telegrams. I've modified it a little bit so that I could do load sharing, and in that live stream I talk about how I've modified the 352 telegram, and I believe I even showed the function block that I use. If not, that's a good one to kind of go through, because I do have a function block that I have that is custom for the 352 telegram. So yeah, let's look at back to the S120. and don't feel bad about kind of getting off topic or anything, because that's what we're here for. We're here to kind of hang out, learn about the automation technology wherever you are in your journey. So the S120 system consists of rectifiers, which I'm going to go ahead and kind of circle on this, a rectifier, and then motor modules. And I have no idea why that is so big, but we could do this. And so what happens is the rectifiers take our AC 3-phase voltage in, like this, makes a DC bus, so rectifies it, and so we have a DC bus, and then our motor modules hang off that and go out to our motors, like this, like that. Real basic. And so yeah, Profinet rather than, yeah. So yeah, Profinet, if that's one thing. So Lucas is saying that he recently graduated from university, and is and sees that definitely the control over Profinet is absolutely, in most applications, the best way to go about it, because you're going to get such easier controls, so much better options and everything like this. And so like in this case, this system, the control unit over here, let me clear. So this control unit here actually has the Profinet communication coming into it. And it's always, it's going to be so much easier to control your system if you have a PLC with Profinet, to use Profinet. And Ali Reza is asking the question. Yes, it is possible to work with hardware. I know that it looks like I'm in a very expensive office somewhere, like in New York City or like that, but it's not. It's my spare bedroom in my apartment. I've tried to figure out a way to kind of do these live streams on site working with hardware, but it's just a little bit difficult, because most of the places where I'm working, it's either during production, and meaning extremely loud, you wouldn't be able to hear me, or it's in an environment that is essentially going to be the same thing as me just showing you how to program everything. In this case today, everything that we're going to be going through with this active line module, I recently set up on a piece of equipment. Yeah, so Ali Rez was asked via remote desktop. I absolutely could hook up two pieces of equipment that are out there, and The word is could. The problem is these pieces of equipment are in production, and like for example, this active line module that I was talking about that was just set up, I have a VPN connection that I could connect up to on this and actually troubleshoot and work with the hardware or show you this stuff online. The problem is it's already set up, and if I change anything, they're actually running production right now, and these are running at about it's 100, so it's about $50 to $75 every 10 seconds. So whatever that math works out to be, it's expensive if I mess something up. So unfortunately, I'm still trying to figure out the best way to give you some actual live hardware. I have a demo unit that I could use. I have an active line module that I am going to set up for in an environment that I would be able to play around with. But me connecting up to that sort of those systems actually would give you a little less information because I can't really change anything in those running systems. But yeah, I'll figure out a way to do that. Like because we do have some stuff that I can show you on that. So with this active line module system, let me go down and show you kind of what the two versions are. So this active line module is essentially this is the rectifier unit. So this is the AC to DC converter, and this is going to be converting. And in the S120 system, you have a version of basic, smart, and active. Okay, basic means it's just a straight IGBT rectifier, no control, no regen. So if your motor outruns and it starts generating power, you have to break that off into a braking resistor or to another motor, supply power to another motor on the DC link. So that's one of the things. Even with a non-regen line module, you can still load share as long as your motor modules are connected to the DC link. So the smart is the first place where you actually get regen. But even though it says smart, it's dumb regen. So it just switches the IGBTs on. If the DC link is higher than the threshold, it goes back onto the line. If it's lower, it pulls power on to the line. So it's smart in as much as it gives you the ability to put power back onto the line, but it's not the active. The active is a power factor correction. So power factor correction, harmonic eliminating, and a controlled buck boost converter. So with the active, if the power supply, if your voltage drops, then it is going to start gating the phases forward in order to keep your DC link voltage set high. Now, whereas both the basic and the smart, if your voltage drops, your DC link voltage drops. Means your torque available out to your motor also drops. So if you're needing good torque control and you can afford to go up to these higher end systems, then active line module is a thing. We'll also talk about some of the other benefits of the active line module, because there's really three things. You have a controlled DC link, you have power factor correction, and then harmonic elimination. So the performance of your system, the performance of your motors, and then the performance of your line. Those are the kind of the two big things that you get by going to an active line module system. And it's kind of crazy at what these things can actually do. So this is just one part of your system. So you could still use all of your motor modules, and if you want to upgrade to active line module, you can still use all the regular motor modules, and then yeah, they work exactly the same. So one thing to note that's on this page is that let's see if I can. One thing to note is this right here. In order to operate an active line module, an associated active interface module is required. So this active line module is essentially taking what you would consider a motor module or a drive and turning it around and facing it towards your power system. And if you know anything about the harmonics that are created by like on a VFD cable, you would understand that would be horrible for electronics, like in your building, for example. In order to do this, they have an active interface module that is a tuned harmonic filter that eliminates all of the voltage and current harmonics from this, essentially a drive turned around backwards. And so you have to use the active interface module. There's some places on some of the documents that we'll be looking at on this stream that kind of like hint that it might be an option. It's not an option. If you run an active line module without an active interface module, you will start blowing up power supplies, anything capacitive in the system. It will get really ugly really fast. So active interface module, always. So the last thing, we talked about that. So I wanted to show you how to connect an active interface or an active line module and an active interface module system. So there's two types. There's a book size and a chassis size. So book size is on the screen right now, and we'll talk about the chassis in a second. So we're going to scroll down and look at the connection diagram. Again, this is in the PM21-4 catalog. And let's take a look at how these things are connected. Okay, so you have your active line module. That is I have no idea why I did that. Oh, actually, I bet you I do. Yep, that's why I scrolled. So you have the active line module, and then you have your active interface modules over here. So if you notice, your line connection is connecting in to the active interface module first. So active interface module is the interface to the line. If you notice in the book size module, it just has filter, a bunch of black box, and then it comes over to the active line module. So we're going to talk about what this stuff is right here. These are the pre-charge resistors and the bypass contactor. If you are not aware of kind of how a drive works, the DC link has big capacitors on it. Really big capacitors if you have a big drive. There's a lot of energy. And so if these voltages are very low and you don't limit the amount of current that is going in to these capacitors at startup, you get incredibly high inrush currents and it will destroy your drive. So every drive system has some form of pre-charging. And so we're going to talk a lot about the pre-charging resistors and the pre-charging contactors here in a second. But essentially what this does is that when you put power onto these big DC link capacitors, it slowly ramps up the voltage and then switches over to full voltage. And it does this just by limiting the amount of current that can go into these capacitors. Okay, simple enough. That's what that is there. So if you notice, the active line module itself in the book size versions have the pre-charge circuits. Okay, so they are really straightforward. You have drive click going to them. So your CU is going to plug into one of these, and you're going to send an on signal. Oops, 0, 1. You're going to send across the drive click, and this will start this up, connect up, and bring up this DC link voltage here. So it'll ramp up the voltage and then make it available, and then it will switch this all automatically, and it will bypass the resistors. Cool. Pretty straightforward. Every drive system has that resistor setup, and so yeah, but you kind of just, it's kind of overlooked on a lot of things. You can't overlook it on a chassis size system. I want to show you how big these things can get, because these are up to like 200 amps in the book size. Well, you can go into the thousands of amps for the chassis size. And you're like, why in the world would you want something that big? We'll definitely talk about some of the reasons why you might want to have something that big in your plant. Obviously, if you have a big motor or you have a big motor lineup, yeah, you need it, right? So let's go through and let's clear this out. So that's the book size. So let's go up to 200 amps or so. Let's go down now and look at the active line module in chassis format. So we could see here that there it goes up to, in amperages, in so 1,405 amps. So that is the rated. So that is actually the S6 rating, I do believe. And so that includes some sort of overload capacity as well. So that's over almost 1,500 amps of the ability for these active line module systems to power a DC bus. So that is 900 kW, 1,250 horsepower that's available on this guy. So that is big. And so obviously, when you start dealing with that amount of power, you start dealing with, you have to start taking into account other things. So whereas in the book size module, everything was built in, you kind of have to, so this is the active line module in the chassis format, and this is the connection example for it. If you notice, first of all, the active interface module isn't even on the same screen. So that should cue you into the fact that, all right, this is a big difference. If you notice also that there's no pre-charging circuit. Okay. So all you're doing is coming in here from the active interface module, and it's its power. So remember, these things are orders of magnitude. Yeah, so these things are orders of magnitude bigger than the capacitors that in those basic line modules. So if you were to blow one of these up, I hope you're not anywhere in the room with it, because there's going to be, yeah, damage, real damage. So let's take a look at where those pre-charge capacitors actually are. Let's clear this out. So Lucas has asked if I run a Discord server. I actually do. I have a couple of them. I have one, my company has a Discord server, and then I kind of have the Jason Watts AE server. I haven't quite figured out the best way to organize that, and that is one thing that I definitely am going to get going, is the Discord server for this channel, and I'll be able to put that out there here in a little bit. But yeah, it's one of those things of just understanding the best way to keep it all together. I do have a Discord server for that's like kind of general type topics like this. So let's go down and look now at the active interface module for the chassis size. And there are actually two different diagrams here. So this is for frame sizes F and G. So Frank and Golf, Foxtrot Golf, whichever one that's supposed to be. And so these are actually the smaller chassis frame sizes. So these are kind of the, I think like the bottom 4 sizes. And we look at this, you can see that the pre-charging circuit is built into the active interface module. Okay. So there's our pre-charging circuit. Now, if you notice, the contactors are not controlled internally. They are actually being controlled by the active interface module. So we have to go through and I will answer that question talking about the harmonic, the production of harmonics, in spite of having the ALM. When you say that, the question is, have I ever dealt with harmonic production despite of having an ALM infeed? Are you saying that there is a active line module that's in service and it's still having harmonic issues? So while we're kind of waiting on that, because the harmonics are part of this filter. Some of it is here, but then there's also a lot of times there is, okay, yeah. So sometimes there are ways that the active features can get turned off, and that will have an effect on the harmonics. And so we'll take a look at that here in a second after we talk about these pre-charge contactors, because this is one of the things I have actually started up a couple of these large active line module systems, and this was one of the things that we didn't realize was going to be quite as complicated going into it. But then later on, we were like, oh crap, this is different. And so I want to kind of give you a heads up that these signals are actually tied back to, you can read kind of down on there that it says that the activation is by the active line module. So let's kind of flip back and forth and look real quick at what this means. So this is the active line module, and there are two signals here that say activation of buffer protection and activation of pre-charging contactor. Okay, so what this means is you can see that when you go to the CU is plugged into one of these drive click ports on the active line module, just like on the book size module, the CU talks to the ALM. When it goes from 0 to 1 and it turns it on, this is going to sequence out and close this set of contacts. Okay, so terminals 5 and 6 of X9 will close when it is expecting to pre-charge. Now, it will start a pre-charging timer, and if it doesn't see that voltage come up, it'll fault out. So it's sitting there waiting for you, or not you, it's waiting for the pre-charging circuit to come in wherever it is, because this thing definitely does not have a pre-charging circuit in it, and it will not, it needs to make sure that those input terminals are correct. Otherwise, yeah, it's not going to be good. So it has the gating circuit here that is looking for that pre-charge circuit. So let's look at where these actually need to land. So you have this buffer protection. I don't know why they call it buffer protection. It needs to be called bypass contactor, because that, I don't know why they call it there, because later on the active interface module, that's the bypass contactor. So let's clear this out and just know, so this is on terminals 5 and 6 of X9 is pre-charging. I'm writing this down in my little notebook. And then 3 and 4 of the ALM is the bypass. All right, let's clear this and get this back here. And then let's look at the active interface module. So again, these are the smaller frame sizes, because the bigger one is even different than this. But we're going to go through both. Give me this. Okay. So we're going to, if you look here, there's an external 230 volt AC circuit that comes in here and then comes over to one side of this terminal 9. So we need to connect, this is for pre-charging. So we need to take this over to terminal 5 and 6 of our ALM. So this is X9.5, X9.6, and then this one, same thing, has power coming down here. And then, so this needs to go out to X9.3, and then X9.4 will come back into here. So that way the control is still exactly the same, because we're going to be using a Telegram 370 and 371, and that control scheme is the same no matter if this is a chassis or a book size module. So there's where we have that. Both contactors, I'll make a note here, both contactors. So this is the pre-charging because it's closing in the resistors. And this is the bypass contactor. And you can trace these out. Yeah. Both of these close in, are internal to this active interface module. And this is on the frame size, frame I, and frame G. No, sorry. That's totally backwards. So there are no, it is the frame size F and frame G, E, F, G, H. And then, so hopefully straightforward there. Let's scroll down to the next two frame sizes up. So these are on the frame H and J. Okay. If you notice, internal to the active interface module, there is only one contactor, and that is the pre-charging contactor. And this is very important, because if you are buying this big of a system, first of all, if you're buying this big of a system, you need to have support of someone that is intimately involved with Siemens drives, because these are the 1000 amp and 1400 amp models. That's the frame size here. You don't need to be doing this alone. And so the pre-charging contactor is inside But the bypass contactor is external. It's a totally separate device. And you could get messed up with this, but it is a totally separate device. It's controlled exactly the same. So 9, 10, 11, 12, same terminals, same thing from the other. The problem is that this bypass contactor, it's just signaling the active interface module to disable the pre-charging contactor. Okay? Because you have an external bypass contactor. All right? So, what does that mean? Well, you are going to have a coil on some other contactor. Fortunately, let's clear this, do this. Let's scroll down a little bit more into the actual technical specifications of these sizes. And if you notice here, it says bypass contactor here. These smaller sizes is included, so it's built in. But the larger sizes, so the top 4 sizes, it's an external bypass contactor. And these are the recommended sizes. So I'll tell you, if you're not familiar with the Siemens kind of like breaker controls lineup, this here is what you would consider like a standard IEC contactor. It kind of looks like a little thing and has the little stuff like that with lugs like this. All right, kind of looks like that. That's what this is. These 3WL, they're not actually a contactor. They are actually a breaker. So they are a 3WL electronically racked breaker. So these things actually are a full high power racking, so like a racking motor, circular rack in, rack out type style of breaker. Just this breaker is like thousands and thousands of dollars. And so while there is just this on-off signal going to this breaker, these breakers are electronic breakers that have to be set up in order for them not to trip. And so whereas this, you just have a set of auxiliaries here and then a set of coils. These 3WL breakers are pretty complex just in and of themselves because they are a high power rack-in, motor actuated rack-in breaker. So when you say close on that, you hear like a and then it like it's pretty crazy. First time you rack in that, yeah, it's nerve-wracking, no pun intended. Yeah, if you haven't had the privilege of racking in a what's it called, like medium voltage or a high power device like this, go watch some arc flash training videos and you will not want to touch them ever. Actually, don't watch arc training videos because yeah, they're pretty nasty. All that to say, if you're doing something this big, get support. So like if you're doing really, all of these chassis size are kind of beyond what you should be using YouTube videos on as your support. You need to have local support, expert industry support for this stuff. But I just wanted to show you, if you are looking up these sorts of things, understand that these larger sizes have external components. So, but they're controlled exactly the same way. So, all right. How's everybody doing? If you're watching this on demand later and you have not subscribed, welcome to the stream. I'm glad, however you made it here, I'm glad you have made it, and I'm glad you have come across this community. hopefully you can go and look at the rest of the channel, look at some of the other videos that are there, and yeah, you can hopefully, if the content's helpful, that you could subscribe. Anybody that's on here right now kind of watching it, it would be great to just go ahead and hit the like button on the stream, because we're going to be going for a couple more hours, and or at least, how long have we been going? We're going to be going for a little while longer. Plenty of time for other people to be able to find this stream while we're going, and it will grow our community. And I will say, just kind of as a little note at this point in the stream, as I start switching over to Portal, this channel is about to the point to where we can start offering memberships. And if you're not aware of what a membership is, it's just a way that you can kind of pay a monthly fee to have access to different features. And I've really been thinking about how to kind of like provide extra to you. And so one of the things that I was thinking about, and I'd love to hear some feedback from you on this, would be for a small membership to be able to have access to all of the data types, all of kind of the library blocks that we make on these streams, because we're about to make a Telegram 370 and Telegram 371 data type that you would be able to control an active line module with. And so my question would be, would it be worth it for a small amount, maybe like $1 or $2 a month or something, to have access to all of the data types and all of the function blocks that we make on stream? Just a thought. I don't really do the YouTube stuff for the money. I do it for the community, but there would be, I think, some value there. And so I'd love to hear your thoughts on it. But yeah, either way about it, I'm going to keep doing this content and making all of this content available to you, just without a membership. And so, yeah, so let's see. Does my head need to be here? I think it needs to be here for right now, because what we're going to do is I'm going to make a new project, and we're going to call this ALM Live. And what I'm going to do on this project is just go in, and we're going to add in again, if this is your first time looking at Portal, I'm probably going to blow through stuff. There are a bunch of other videos, live streams, and videos about how to get started with Portal, how to set up S120s, how to kind of do telegrams and stuff. I'm going to assume that you kind of know that sort of stuff and go straight to the 370, the stuff specifically for the active line modules. What I'm going to do is I'm going to throw in just a basic controller, because we really don't care what the controller is. I'm going to throw in the alpha special, the CPU TF, the 1515 TF. This is our standard kind of medium to large size project for our agriculture or small motion projects. So like our winders, this is what we use. And I'm just opening up everything on this. Again, we're going to, as always, name our PLC, right? We're going to name all our devices, because naming your devices saves you headache in the end. And just want a PLC to be the controller so that we can put some code on later. Profinet PLC. And we're going to add in drives and starters, Dynamics drives, Dynamics S, Dynamics S120, a control unit, because all of our S120 systems require a CU. Okay, so we're going to do drive CU. We're going to keep going here, and I'm going to assign this to our PLC. And now I'm going to go in and go into our device view, and I'm going to add in an active line module. And I'm going to select, we'll just select, say, a 60 amp. Just random. And let's add in a couple of motor modules. Just for the heck of it. Just to kind of show how this would be. Let's select like a 9 amp for both of these. And we're going to bring in a couple drive click motors into these guys just so that we need the parameters for stuff. They'll be there. Again, drive click, the reason I use drive click is that way I don't have to go through and set up absolutely everything. It just assumes that there's going to be the motor data there. And the last thing I want to do is go in and set up the basic line module details. And so I come in here and I say, okay, I want to make sure that I have an active interface module that is appropriately sized for this. This is going to be tied 1-to-1 out of your PM21-4, or I guess not PM, I guess that's the old one. It's the D21-4. It's going to tell you exactly which one of these it is. And so here's the active interface module. That's how you select it. That's really actually all it needs to know is that, hey, that is the one that's there. What we want to do now is talk about the communications for this. So you may or may not be aware, but all the communication in an S120 system is connected through the CU. So you have one Profinet address, you have one kind of network node, and then it breaks out into all of the different sub or drive object numbers. And so what I want to show you first is where these show up. And so I just clicked on this dark CU portion, and by default it comes into the Telegram configuration, and that's what this screen is. And yeah, you can see me. I haven't blocked. Here, I'll go over this other side here. And so that's what's over here is the telegrams that we have configured. Obviously, right now, we don't have any telegrams configured. And I want to show you a little bit about this. Once we bring this into the hardware configuration and we have assigned it to a Profinet controller, it gives us the partner data areas. Okay, so these I-256, all of that. Well, it also gives us the hardware identifiers for those telegrams. All right, so those will come up later, but just remember that's where this data is for. I talked about the drive object number. Right now, we have 4 objects in our device view, right? We have 4 drive object numbers. We have the CU, the infeed, and then 2 drives. So that's 4. So that's what this item number is over here, is simply the actual drive object number. Again, that'll come, we'll work on something later using the Sina infeed block. We'll work through that, and that'll be necessary. Actually, that won't be necessary for that, but we're going to be doing something later, something super cool, and we'll need to know what this drive object number is. So we're going to talk about the fact that every one of those drive objects have the option for a telegram. So right now, the free telegram is just a 1-1. So you're always going to send a little bit of data back and forth, but by default, it's just 1-1. Most of the time, like our drive objects, which, by the way, if you're using, these are set up as servo. If we wanted to set them up as vector, we would have different opportunity or different telegram numbers. So, and you notice when I changed that, it took away my motors, right? So we'll just leave these as servo for this because we don't really care about this for the active line module. Throw these motors back in. Click back here. telegram. So really the only thing that we're worried about right now is the infeed. And what I want to do is go through and just talk about the two different options for the infeed. We have a 370 and a 371. Now 370 is, as you'll see here, is just a 1-1. And there is a block in the Dynamics Drive motion catalog that we'll show you here in a second that uses Telegram 370. And 370 is essentially just a control word and a status word. There's no other set points, no other anything. But we'll see later that that might not be exactly enough for what we're wanting to do. So let's just go right now and look at 370. And I want to show you, go back to a different manual, because I found this out. Today, actually. I learned something new. When I was going through and setting up for this stream, I was making sure I wasn't going to make a fool of myself. And I started looking up the telegrams, and I didn't realize that in the list manual for the S120, it details out all of the telegrams that you can use for an S120. And so I did not realize this. And so I didn't realize this was in the list manual. And the list manual is kind of the manual. If you ever talk to someone that complains about how many parameters the Siemens S120 has, they've opened up this list manual and saw the 10,000 parameters that are in the list manual. And they're like, that's too complicated. Well, the S120 can do any system, and the number of telegrams is evidence of that. So here's your standard telegrams. And by standard telegrams, let me zoom in a little bit on this, because your standard telegrams are anything that is less than 100. So those are industry standard. Your other manufacturers are going to be adhering to these same kind of telegram configurations. And you can see here the different words and the different names of what it is. So like a standard telegram 1 is a status word. So the first is, you can kind of see here, receive direction from the PLC. So this is from the drive's perspective, what it's receiving. So that's going to be the control word. And then, so that's going to be in set point. And so that's going to be the speed set point. And then you can see the speed instantaneous is getting sent back. So standard telegram 1, control word, status word, speed set point, actual value. That's status 1. And so this is in the list manual. All this information is here. So I also have a full live stream and video about telegrams that you can check out too. And if you check those out and you find them helpful, be sure to like it. And if you're not subscribed, subscribe. But the one that I wanted to talk about are the manufacturer specific ones. So these are all Siemens manufacturer specific. So these are, we use these 103, 105, 111. Those are all the ones that we use different technologies for in Siemens. So for example, 111 is if you were using the electronic positioner, EPOS, you're going to have to use the Siemens 111. And well, here, it tells you where all of that stuff is. What we are going to look at, we want to see telegrams 370 and 371, okay? Because what we want to do is we actually want to go through and make a data type for the 370 data type, okay? Just so that we can break it out, just so that we can use it, because you don't actually have to use the Sina infeed block if you do it this way. And I want to show you how to do this. So we're going to go through, and swap over to, which before I get off this, I'm getting distracted. First time I've ever gotten distracted. Wanted to show you. So this 370, it's ESTW1. And so we go over here and find ESTW1, and it tells you what each one of those signals are. Okay, so this is what I'm about to be putting into my my PLC data type. So the Telegram 370 is just a control word and a status word. And I want to try and make it to where when I flip back over here, if I do, then you can see it. But this is what I'm going to be using to make it. And now one thing to note, that what you're going to see here is the on-off one is bit 0, but and so you have this bit 0, and then bit 10 is control word or control by PLC. So if you're not used to dealing with communication back and forth to drives, remember the bytes are swapped. So this on-off one is actually going to be down here at 8, and I'll show you how that looks in the data type here in a second. So how y'all doing so far? Learned anything new? Hopefully you have. We're gonna save this. I see a bunch of people that have been in chat before, and so y'all are gonna be familiar with making these PLC data types. But what we're gonna do, if you're not, we're gonna learn. So we're gonna do E_STW1. Okay, that's what this name is, and it's gonna be a Boolean, right? And it's gonna be, we're gonna do it this way, and you'll see why. We need 15. Isn't that nice? And then now we can just go through, and starting at 8, this is going to be on off 1. Remember, like I said, these are byte swapped. If you don't know why that is, don't worry about it. No, it's just the way that bytes are being transmitted into the buffer. It's one of those things that if you want to understand why, you can, but you don't need to. So enable operation is 3. And you might be sitting here, why am I doing this PLC data type? So skip. This makes it to where when you make a tag, we're going to point it to an address, an output address. For this one, yeah, I guess this would be an output address. And it will just automatically send that data over to the Telegram. Because when you make that Telegram, we want to make it to where we can access the individual tags, make it really easy to be able to work with, and that's what we're doing here. And obviously, you're probably only going to have one active line module, but if you use this multiple times, you can just use your data type, and it just works. Inhibit motoring, inhibit regen, and then this is going to be acknowledge false. Okay, and then now we go Where do we need to go? So 8, 9, bit 3, or the third bit. So 0, 1, 2, 8, 9, 10. Control by PLC. And one thing about this control by PLC is you have to turn it on, otherwise it'll reject any communication from the PLC. So that has to be on, and you go from there. So then 1, 2, 3, 4, 5. So 1, 2, 3, 4, 5 right here. This is sign of life toggle. Apparently there's a toggle bit in there because it's important. Okay, so we made our this is our control word. Now let's go through. I'm going to click on the EZSW down here, and I'm going to do the same real quick for E_ZSW. One. Yeah. Then we're going to do the same thing. We're going to do 0. We're at 15. And then we're going to go through and look at 8. Let's do it this way. So 8 is going to be ready for on, ready for operation, operation enabled. Again, these are all in the list manual. In this case, it's on page 2138. Real easy to find. It's actually chart 2430. You want to look that up. So this is operation enable fault present. No off to. Yeah, the way the Germans name this, that just means, so there's an internal off to. So like if there's for some reason it can't enable, it'll throw that, and so that's kind of like saying, hey, something's cutting you out. Even though you're trying to enable it, you're throwing the off one. If that no off to effective, that'll be on. So let's look at 6 is switching on inhibited, which that is another way of saying that. And then alarm. So while we do this, anybody got a cool project they're working on? Anything fun in their automation world? 6, 7, 8. PLC requests control. That's then pre-charging is complete. Skip. And one of the things about these, making sure that that you make sure you get these right, because otherwise, 1, 2, yep. Because you're going to be using, especially these, you're going to be using these. These are the signals coming back to you for your PLC code of. Okay, so we've got our status words, and that's honestly it. Okay. And so what we can do, here's the crazy thing about the 370 telegram is this is all it is. There's no extra data. So what does that mean? Well, now if we were just wanting to use the 370 telegram, which did we set that up for 370? Yep, we did. So we can just go and make a tag in our default tag table called ALM send. And now we can make a E. We're sending it. And that is not going to be there. And now we can look at the address here. So this partner is 258 for both of them. So for what we're sending out, 258. Q258.0. And then we do ALM receive, and it's an E CSW, and it's I258.0. So now when we go in and look at these tags, each individual bit is called out. And so our control by PLC, all of that. And once you establish communication and both of them are communicating with parameter 370, then you're going to be good to go. And one of the things about when you go to start one of these up, you start this up and you would just download, and it would download the 370 telegram into the hardware, and it would download any of the setups that you're needing. So yeah, we've done this process quite a few times, but I think this is the first time that we haven't had to have two separate kind of embedded a PLC data type inside of a PLC data type. So what do I mean by that? Well, if you wanted to extend this out, which we probably will do here later, we're still going to use the ZSTW1 as the first word, but then we're going to want extra data, you know? So, and there's a reason why you might want to do that. All right, so at this point, if we wanted to control this block, okay, we could literally go in and say, for whatever, let's just do in our default, let's do a user constant called no-op, and it's a Boolean, and its value is false. And so we're gonna do not no-op, and we're gonna kind of go in and we can do now ALM send dot control by PLC, and then kind of go down through here. Going to do the same thing, and then we would go through ALM dot send enable operation, right? ALM send. We don't want those. We do want an off 2. Off 2 is like an emergency stop. In general, you would want it to be shut off by the off 1. It doesn't shut off immediately, but it's less likely to cause damage to your equipment. Obviously, if you're trying to protect someone, then you want to do the off 2, because yeah, you don't care about the equipment, you care about the person. So what I'm doing is just going through and looking at all of the control bits that are needed in order to get this thing on. And I think that's it. Yeah. So you have to have the control by PLC. you have to have the enable operation. You obviously the inhibit motoring and inhibit regen, you don't want that high, because unless for some reason, like, I don't know why you would do this, use an active line module on a generator, but like a generator, you cannot regen. And so you would use this 370 and say inhibit regen. And hey, I'm running on a generator. Like if you have a generator backup, for example, maybe that's one reason why. Your generator backup kicks on, bam, then you need to say, hey, inhibit regen. And that's what that would be. And then so at this point, that's kind of the things that would be on all the time. And if you had your default tag table, we'll do another one. We'll call it just a Boolean called startup complete. And this is just a Boolean. And I'm doing this, and we'll call this, watch. Actually, I'm going to show you how to do it this way. Instead of doing it that, we're going to say, all right, when this is on, we want to enable our ALM send. We want to enable our on-off one. And this is startup complete. And we're just going to define tag. We want it as a global memory. We'll just define it. All right, so that would be just the basic control. So now when this comes on, all of these bits would be enabled, and this bit would be the toggle to go on and off. So when your startup is complete, it comes on. So straightforward. This could also be like a push button to enable infeed, and then you could do, that's where your logic's going to be. So that actually turns on and off the ALM. Okay. So here's the second way to do this. We're going to use Sina infeed. By the way, the 370 Telegram is available for the smart line module as well, and even I think there's even some versions of the basic line module that you have to turn on. But anyway, that's those. It's the same thing. So I'm gonna move my head over to this side, because now I've downloaded this optional package, and honestly, it might actually come in TIA Portal. Now, if anybody knows if the Synamics, Synapod, Synapera, Synaspeed, like all of those, Sina infeed, if anybody knows if that comes in the default installation of Portal, throw it in chat, because I don't remember installing it into version 17, but I also don't remember a lot of things. But optional package, Sina infeed. I'm gonna drag this in, call it whatever, don't matter. So this kind of handles all of this information. So by default, the config access is what you need. It essentially sets these things. It's this network. All of this is the config access stuff. And so I'm going to put this as, actually, I'll show you how to set it up. So remember we talked about the hardware IDs earlier? Well, remember, so we go to our device view, our drive CU, we click on the little dark portion of the CU, go to Telegram configuration, and we find our infeed Telegram. Okay, and then we get this to where we can see it and scroll over, and our hardware identifier is here, 269. So I'm going to write that down. 269. Nice. I lost my not pen. So another way, we could just type that number in at that interface, but it doesn't look nice. It's just a number, right? Control 5 to drop this down. Control 5, get out of here. We could type in 269. And that would work. It just doesn't look as good as it could, because what we can do is if we just start typing, we say, hey, and we hit the little box. We have drive. It brings up anything that would be accepted here. Okay. So kind of move this around a little bit. Got to move my face again first. Sorry. So I move this to where you can kind of see it, but in these, I do not want to do that. We have these different, like where it says free Telegram, Axis 1, Axis 2. So we can kind of scroll down through here. And if this is the first time you're kind of looking at this, it's like just a random bunch of stuff, right? Drive Axis 1, module access point, blah, 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 blah. Well, we scroll down through here, infeed 1, Telegram 370. And then we hit enter, and look, it looks like we know what we're doing. And you do know what you're doing, because now you know how to do that. And if you know that, remember, the way these telegrams are set up, they're based out of the CU. So I could just start typing drive CU, and then I could scroll down and find the infeed one. Now we'll show you something. I click this module access point. That is a different number. A different number. If these two are different, this will not work. Well, I say that. If for some reason you come over here and your there are ways to have a hardware ID that is not the same. But so just check to make sure. But if you use the hardware ID of the Telegram itself, it will be correct. So we can obviously just Control C, Control V this, and there you go. So that's the hardware ID of the Telegram, and that's really all you need at this point to get it going, because this makes the link just the same way. It does all of that annoying stuff that we did with the creating that Telegram or creating these PLC data types. You don't have to do all of that. You could just use the Signa infeed and go from there. Problem with using the Signa infeed is it is restricted. You don't have like access into the Signa infeed. You can enable pre-charging, and then so we're gonna just go here real quick, do a no op. The second this comes up, it's gonna enable pre-charging, so it's gonna pre-charge, and then we're gonna do a same thing up here. We're just gonna do the startup complete, and then that would turn it on. So yeah, so real easy, real simple. That's the Signa infeed Telegram 370, and it gets you going, and that works with the smart line module and the active line module, and yeah, and that's it. Now there's a lot more to do with the active line module, because we have made it through, at this point, an hour and a half of this. Thank you all for all of you guys that have made it through all of this. Again, I love seeing the guys that are always on the streams. Y'all make this community awesome. If this is your first time on stream, be sure to drop in the chat where you're from, say hey, and like the stream to get it out there to more people. But we're going to go in and kind of start setting up some of the things and actually configuring specifically for the active line module, because this thing is stinking awesome. And you might be saying, hey, Jason, like you're just nerding out over something dumb, but I kind of am, but it's not dumb. It is super cool because this stuff, you saw how big these things get. Okay. So 1400 amps on one, and you can parallel up to 4 of these. So I didn't tell you that before. So this, you can actually, with the low voltage version, you can do almost 6,000 amps of power going into one DC bus system with this. It is crazy. And one of the reasons why you would want to do this is because this is a cheat code for line supply problems. So if you have brownouts or bad frequency like regulation on your line, if you have high voltage, low voltage, if you have inconsistent line, then the active line module will solve almost all of your problems. Because once you set your voltage set point, yeah, you heard me right. Your DC link voltage is now a set point. It's not an equation. And so once you have set your DC voltage set point, then it is going to phase in and out. It's going to do whatever, all the black magic like stuff in order to keep that voltage. So if your line voltage starts to drop, it's going to start phasing forward and it's going to keep that DC link voltage up. If it starts to rise up, it's going to start bringing it back and it'll keep that DC link voltage at whatever it is. So it is super cool just in that fact. So that means if you are in a 360, 400 volt country, you can actually run 480 volt motors with their 480 volt specs. And so that means you can get extra power out of your motors because you can use those higher speed specs. So pretty cool stuff there because you have that extra voltage to work with. One of the things that the problem though is if you are in the US, it is actually kind of difficult to get this thing set up to where it is in what's called active mode. And I'll show you what I mean. We're going to go into the parameterization for the active line module. And what you will realize pretty quickly if you are in the US and you set up back here, let me close some of this stuff out. I won't close that out. Close this out. Close this out. If you're back here and you set up this ALM here and your basic parameterization, you clicked on this button and you went in to here and you said, okay, I need to do line operating mode. Okay. And you went in here and you said, all right, this is on a 480 volt line because, and it lets you, and it's fine. Okay. So what happens is by default, everything is set to 648. And that's actually because it's saying unregulated DC link smart mode. And you say, nah, I want a regulated. And I'm clicking and it don't work. So it gives you this little warning here that kind of talking about this problem that we're talking about. So on a 480 volt line, by default, this active line module will boost your voltage 1.6 times. So it's going to be boosting your voltage up to, I think it's like 720 volts by default or something, the default settings. Well, if you have a 480 volt motor, most likely your voltage So the insulation voltage rating on that motor is probably not going to be over 700 volts. So there are a lot of motors that are even inverter duty, that this voltage will actually damage the motor. So this is one of the things that you're like, oh, hey, active line modules solve all my problems. Well, you gotta have a pretty good motor out there, because otherwise you're gonna start burning up windings, because by default you're over 700 volts continuous. And I'll show you, if you're not familiar with the way that let's do this. Let's go here, let's go here. Just a real quick lesson in kind of like drives. The DC link voltage, the way that you create a voltage for an active line module, this will be 700 volts or more, okay? And so this is 700 volts up here. Well, in order to trick the motor into thinking that there's an AC signal, because all you're doing is switching a switch in that inverter on and off. And so you will switch the switch on and it will see 700 volts for a small period of time. And then you'll wait, and then you'll have a little bit longer period of time. And then a little bit longer. And I'm exaggerating this a little bit, but not too much. This is what the pulses are actually outputting. And when you do an average, of that line, it's going to go, and from here, it's going to start going up, and then down, like that. And so this is what the motor sees, because the motor can't react instantaneously, right? But it is switching on and off 700 volts. So your windings of your motor, while the voltage may not, or the current waveform is going to look like this, the voltage is seeing 700 volts over and over and over and over again. So you have to have a pretty good motor in order for it to do this. Now, 1PH8 motors, anything in the MC catalog, the Cymotics catalog, that D21-4 catalog, handles an active line module. They're rated for it. You're good to go. So if you're buying a Siemens motor, 1PH8, 1FK7, 1FT7, 1FL6, like all of these like other motors that we talked about last week, you're good to go. It's when you get into motors like the SD100 or the GP100, those sorts of kind of induction motors, you can actually burn up the windings just because you're running on an active line module. So that's what this whole like little thing is talking about. And if you read this little kind of like dialog box, it says, hey, just be sure we'll let you turn it on. But then it's not letting you turn it on here. And you're like, what the crap is going on? And I want to see if we can if it'll let us do this from this little dialog box, because I know what the problem is. If you turn this to 460, yeah, so it's not letting you do it from the dialog box. It's making it difficult on purpose, because this is a pretty big deal. What I have found is that it will let you turn this on if you put this on 460, but apparently you have to do it here in parameter 210, 460, do that, and then now we go to parameter 3400. I say that. Is it 34? Yeah, it's supposed to be. So, I must have not. 3,400. I didn't type it in right. And so, of course, you knew that off the top of your head, right? Well, so smart mode is off. We want it to be off because smart mode takes our active line module and turns it into a smart line module, and we do not want that, because what happens at that point is it acts like a smart line module. It doesn't regulate the DC voltage. It doesn't do kind of the stuff like the power factor correction, and that's why we bought this more expensive unit. So it's interesting to note that if you're on like a 400 volt line, 360 400 volt line, you're good. It doesn't complain about any of that. So the first thing that we have to do is set our voltage. We have to lie a little bit and say 460, which, if you've noticed on most American motors, they're not rated at 480. They are actually rated at 460. So it's built into kind of the rating system of this that it's kind of expecting it for that. So we've done this and got our smart mode off. So this is actually going to be running and regulating our DC link voltage. That's step one. Now, this thing, when you start it up the first time, when you activate it, it will do what's called a line identification. And it is exactly the same thing as a induction tuning. So like if you're doing like a vector control motor and you do the stationary tune, you hear like the little bzz, 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 like the buzzing, whining, little pulses. You're going to hear that coming from the active line module, because it's actually going out and identifying the transformer, the line impedances, the line capacitances, all this stuff in order for it to be able to operate correctly. So it'll do that the first time, and you need to, I normally do that and get it on before I do this start, like set the voltage and everything down. Just for reasons like preference, honestly. But the second thing that you're going to need to do is determine what your DC link voltage is going to be. Now, if you are set onto a 460 volt line, then you're probably going to want it around 700, 710, 720 volts, something like that. This thing will actually boost up to 2 times the input current, input voltage. So this thing can actually output over 800 volts. Like, this is a crazy cool thing. And so what I'll show you though is the parameter that is called step up voltage. And it is very close to the voltage set point. So we're going to go to, if you noticed that parameter 3400 is kind of the starting point of all of our 3400. This is kind of all of the infeed configuration. So if you haven't noticed this, if you've been around Siemens for a while, that 200s are power module, power supply, 300s are motor, 400s encoders, and then so on and so on and so on. Well, 3400 is in the active line module, is this kind of the infeed configuration. So we're going to go down to, and I have a cheat sheet here, by the way. So that's what I'm looking at. We're going to go down to parameter 3508 first. So keep scrolling down. 3508 is the infeed step up maximum. Okay. So by default, it's set here at 2 on a 480, 460 volt line. set it at 1.6, because what's 1.6 times 480? What is that? Calculator right there. That's what I want. So 460 times 1.6 is 736. So that's the most that you're really going to want it to step up is into that 750 range or whatever. And so like there's no real reason, unless you are having a lower voltages and you're having brownouts, that you would ever want to step up higher than that on a 460 volt line. Now, if you're on a 400 volt line and you're kind of doing the tricks that I'm talking to you about using those 480 volt ratings, yeah, you would want to boost it up higher. Because if you drop out to like 360 volts, then you're going to want to boost up. I've got a document pulled up that tells you kind of like, you remember that engineering document that we talked about a few weeks ago? It details out kind of the maximum voltages that you can output voltages based on certain frequencies and things or stuff like that. It's pretty cool. Off subject though. Then the second thing you want to set is your DC link voltage set point. Okay. So I set mine to 700 volts, and like in a 480, 460 volt environment, I set it to 700 volts and it nails it. And if you notice, 700 volts is actually higher voltage than what a default 620 volt is. So that means that you can actually extend your voltages. You can output higher voltages at higher frequencies. And so you can kind of tweak those motor curves. It's super cool stuff. Way too advanced for what we're talking about right now, because what you need, set it at 700 volts and you're good to go there. And that honestly is the basics to get you going. You've got it out of smart mode. You've got it into active mode. You have set it up to where you're not going to completely torch your motors if you have an over voltage situation like in the US. You can get up to like 490, 500 volts. If you do get that and you have it set to 2x, it may for a moment like really spike up the voltage there. Those are kind of the basic settings. Now, here I'm going to nerd out a little bit on you on what you can do with this device and what sets it up as kind of a line power modifier. Like it takes care of so much, because out of the box, this thing, whatever you hook up to it, it gives it a unity power factor. And if you're not familiar with what a power factor actually is, it's a little bit of black magic to kind of think about. But in essence, or in math, it's if your sine wave that is your current is not completely lined up with the sine wave that is your voltage, if there's any phase shift in the two, then whatever that shift is, if you have, it's kind of hard to do it this way, whatever that shift is going to be creating what's called reactive current. It's going to be creating reactive power. And that shift is essentially unusable. And so the power company will be looking out at your plant and will say, hey, I'm sending out, say, 1,000 amps. All right, whatever it is. I'm sending out 1,000 amps at 480 volts. That's what they're sending to you. But you're sitting back and you're sitting there saying, hey, I'm only using 800 amps though. And depending on how you are getting billed at your plant, that is because the reason that difference is there is because your apparent power, which the power company is sitting there saying, hey, you're using a 4800 kW, or so 4.8 kW, whatever it is, 48 kW. You're using 100 amps. That's apparently what you're using. Well, you're sitting there saying, I'm only using 800 amps. I'm not using 1,000 amps. I'm only using 800. And so that is your actual, so your real power. So that's kind of like what is actually being used for work. So current in your motors. Well, that difference, depending on how you get billed, your power company could be saying, hey, guess what? I'm going to bill you on 1,000 amps instead of 800 amps. Most of the time they don't, because this is a really big problem. Most of the time they will sit there and say, hey, if your power factor gets off, I'm going to charge you at a higher rate. But what this system does is it corrects that phase shift. So if you have 1,000 amp or 1,000 kW, or sorry, like a 500 kW system, that out of the box is going to be a unity power factor. So the apparent power and the real power will be exactly the same. So if for some reason you were getting billed on apparent power, then, and again, like I said, most places aren't, but if you are, this system will save you a ton of money really fast. Because if you've got a couple of motors sitting out there that are shifting that apparent power, your power factor is going to be off. It's going to be lagging, leading. I can't remember which one it is, but it's going to be shifted off. And you putting those motors onto this system lines it up. And all of a sudden, whatever you are actually using, that is what you were paying for instead of the apparent power. Now, here's the catch. The reactive current on this is actually a set point. Hear me out. I might have just confused you a lot of why this thing matters, like this whole power factor thing, but just know that this, out of the box, it is default as a reactive current set point of 0. You can actually inject lagging or leading reactive current just by changing a set point in the drive. So that means you can actually correct for other power factor problems in the other parts of your plant. And the way this does this is by shifting when it is pulsing those pulses. And so it's pulling, it's crazy. In the engineering document, it goes over the entire thing of how it actually does this black magic. And honestly, I'm not really smart enough to understand exactly what it's doing there. I know it has something to do with magnetic fields in the motors and the differences, but I don't know. really. But you can be a hero if you could start correcting for power factor in other parts of your plant. And if you have a piece of equipment that has a few hundred amps of load, and you can shift it lagging or leading, you're saving money on these like capacitor banks that are up at that they like switching in and out for power factor correction capacitors. Or, oh my gosh, I had one customer that I told them about these, that they were running on these massive synchronous motor gen sets just to correct for their power factor, because they had motors that were the size of literally an apartment, one motor the size of an apartment, and it was crazy. So I want to show you a little bit. Let's go to this. About what you can do with this. So I'll show you here in a second. We'll go back here, and I'm gonna throw this back up on this other screen. So you can, if you have a little bit of extra power available to the I guess, extra rating. You can derate these active line modules and then shift that power factor lagging or leading. So what this shows here, and where's my, I've lost my pen. my not pen. So what this graph shows you here, and again, this is in the engineering manual, and it shows you if you have a unity power factor 1, then you get 100% of your rated current of your active line module. Well, what this is showing is that down to a minimum of 75%. So if you can derate your power module by 75%, or active line module by 75%, and then still provide your load, you can make that a 0 power factor. So, or near 0, because you can inject positive or negative reactive current, and down to 75%, you can basically make your load completely capacitive or completely inductive. And so if you tell somebody at your plant to be like, hey, I have the ability, or I learned about this technology that can shift our power factor just by changing a set point. If they're paying the power bill, they'll tell you, tell me more. Come on, tell me more. All right. And you can tell them about this, and they won't believe it. They won't believe it at first. But actually, hopefully he will see this. He'll see this, because one of our long time chatters and guys in the chat, when I told him about this and I was installing one of these in his plant, he was like, I don't believe you. But here, it's completely true. And so what this means is, say you only have 100 amps of motor out there. Well, there is a kind of like cutoff on these, a cutoff on the sizes of these like units. And so you end up getting these kind of like breaks, right? Well, you can sit, and if I could zoom in on this, say I have 100 amps of current that I'm using. Well, I'm gonna have to use this 134 amp system. And so what I can do at that point is say, okay, I'm only ever going to use 100 amps. So I'm going to shift my power factor on this by 34 amps. So I'm going to inject a reactive power of 34. Or it actually could be whatever. It's not exactly 34, I guess. You would have to do this equation. So you're shifting your power factor, whatever that percentage of that is, and then you would have to derate it. But it would be a fairly simple kind of to figure out, okay, I can shift this by so much on this curve to be able to figure out how much you'd be able to use. Well, the customer that I was talking about that had that huge motor, it was a steel mill, and they have all of these like roller motors on the big ingot, sliding it back and forth. Well, they put a bunch of these really big active line modules in there, and essentially what they did was used all of those motors that were running to move this ingot back and forth at any given time. They cranked it back, and they sized it so that the maximum load, they could run this at almost the maximum. Like I think they had this was a hugely inductive load, and so they needed a really high capacitive load, and so they just cranked that back to be completely capacitive. And so what I'm going to show you here, is I'm going to go back up to our back up to the screen, bottom left. Yeah, that looks right. And I'm going to show you the reactive current set point. It is 3610. All right. And I'm going to hover over this and bring up the help for this parameter. And make sure that this is the one that I want. Yep. And so this is the help file for it. So obviously there's no 10,000 amp module. This is just kind of the maximum. You can do it up to the maximum of your system, I guess. So if it's negative, if P3610 is negative, your inductive reactance. So it creates an inductive load. So it makes this really big capacitor bank, because remember, we got these big capacitors. It shifts it inductive. If you make it positive, it'll creep that forward and create a capacitive load. And that's all in one setting. So one of the things about this is you can sit and say, all right, there's a couple of places to where you can look at this. Oh, is it getting dry? I'm just getting excited, man. Getting excited about all of the cool stuff you can do with this. So I want to show you up here. There is reactive current set point, reactive current actual value. So these are things that you could put into those extra telegrams coming from here, or you can pull these out honestly in any other telegram. Talk about free telegrams. There is a what's it called? A live stream about free telegrams where we go through and set up all sorts of stuff, so you can see how you can bring stuff back. But you have this a couple of these values that you can actually pull into here. Up here, parameter 38 is our power factor smooth, and it honestly would be the best thing to get if it was just our power factor, right? Unfortunately, let's go down and look at like our PZD telegram somewhere down here. Like if we wanted to send this out, let's see, that's 2050, I think. Send word 2051. So let's try to send out parameter 38. It's just not there. It's not available for us to send out. Now, there is down here a place, I didn't show you this, and for our reactive. So this reactive current supplementary set point, if you notice, this can be tied in as a BICO. And so you could put this in from our Profi drive, receive word PZD1 or PZD2, right? So remember, again, we've talked about this in free telegrams. If you're not sure how to get this set up in it, look at that. And yeah, I might have to do a stream or something on this. But what you would do is you would just actually, whatever, I'll just talk about it now. So if you wanted to extend this out, for example, right now, this drive telegram is a 1-1. Okay, it's parameter, it's telegram 370. Well, there is this telegram 371, which is an 8.5. And if we look at what that 371 is in our list manual, let me find it, throw it up here. We see that the data coming to the drive is actually just, it's 4 words of free data, which is exactly what we need. So if we just change that to 371, we're still using the same, well, actually, we will need to check and make sure that the value is the same. Yeah, it is. So E STW1 and Z STW1. Yeah, that's what we made earlier. And so, so swapping this over to 371 immediately gives us pretty, like, really 3 really good things. So 371 is, we get all this user data coming back from the drive, we get an instantaneous current, and then we actually get the fault and warning codes from the drive. So this 371 actually seems a lot better than, honestly, the 370 telegram. Now, here's a little trick. I know some of you would be saying, well, crap, we can't use this sign a telegram anymore, right? But you actually can. And here's why. Because these use the same control word and status word. And that's all that sign a infeed is looking at. Now, you have all this extra data that isn't coming into the sign a infeed block, but you can still use this pre-canned block with a 371 telegram. And now, when I connected this over here to, so the infeed reactive current supplementary set point. So if we want to swing our set point back and forth, I'm going to set this to PZD2. Okay, pretty good. But now I'm going to do a little thing, because now I have this different telegram here. And so I have extra information that my tag isn't quite set up to be. So I'm going to go back and modify, actually create a new PLC data type. And so I'm going to make this ALM 371 send with reactive set point. Okay, so we're gonna do that. Now I'm gonna show you. So I'm gonna do control word, and I'm gonna make this a data type. What's it? E STW1, right? And this is just going to be an integer, right? Because we're wanting plus or minus, and it's in a percent. And so we're going to call this reactive set point. And this is just going to be an integer. Okay. We're going to save this. And now we're going to make our tag, our PLC data type. We're going to make our tag a new, because let's go back and look at our output word and make sure that it's still in the same spot. Q264. I don't think that's the same, is it? So is not. So since we have changed this, we need to change this to a type ALM 264 Q264.0, and now that reties in that new tag. Now this ALM receive is pretty much the same thing, but we're going to do pretty much the same thing for this other data type. So we're going to do ALM 371 receive, and Are we going to be sending any data back extra? Let's send back with reactive. Okay. We're going to do the same thing. Status word. And again, this is kind of like the common way of going through and setting up all of these. So we're going to go E, CSW. Now we're going to need to go down and look at this again. So our next word is going to be instantaneous current. So we'll call that actually we're going to do no, that's right. And this is going to be warning then fault. Is that what that was? Just looking at these. Yep, warning then fault. We're going to actually name these. These are unsigns. And then this next one is going to be actual reactive. Okay. And that is going to be an int. Okay. And so now we're going to go back to our default tag table. We're going to rename this to our new tag. Receive with reactive. Send, receive. And we're going to point that to the correct place, which is still 264. Ah, 264. Now we have all of that information coming in. So now we have current, reactive current, we have the reactive current set point. And if you wanted to modify that, simple move block, math block, all of that stuff. So that's how you would do that. So yeah, so that is kind of this reactive current thing. I wanted to show you one last thing though, because we brought up that R38, right? That we would want to get. So we were looking at this and we really wanted to get that R38, right? This guy right here. I want that. I want that power factor, right? Because that would be so valuable to just be able to put up on the screen to tell your manager, look, our power factor is perfect, right? Well, what we can do is instead of, we can't use the cyclic communication, but we can use acyclic communication. And that is built into the Sina para S function. And the way we use that, so we are going to be reading a parameter. We want 38. We don't have an index. We're not writing. Our axis number is going to be the axis in here. So our infeed is number 2. Here. So this is going to be 2. Our hardware ID, we should know from that, but it's going to be drive CU. We'll go down here. It's this telegram. Okay. And that's it. And so we can do start, and we'll just make this kind of like all the time. So we'll just do a no up on here. All right, so that actually gives that information, and that will pull it. That will pull that data back, and honestly, the value read will come back in here because it will be a real value. So it goes in and actually determines whether or not that value is an integer or a real. And one thing to note about if you're using this sign up para S block is go to your actual. So if you go to this value, so R38, and then you go to help for parameter, and I'm just hovering. I'm hovering it until that pops up, and then clicking the down arrow, and it brings up a help file. You have this scaling here. If you notice here, there is no scaling. Most values, like this DC link voltage smooth, for example, if we do the same thing for it, it has a scaling parameter, P2100 or P2001. And if we go down here to look at that, P2001, that's 400 volts RMS. That's the reference voltage. So the value in, if we were to actually pull back this DC link voltage, it would be scaled to 400 volts. So obviously the maximum that voltage is going to be able to be is going to be 800 volts, right? Because we only have that one sign, or the one bit for 200%, because all of these integer values are the first sign is the sign, or the first bit's the sign, the second bit is up to 200%, and then 100%. So it's technically a 14-bit integer instead of a 16-bit. So we might run into a problem if we were to ever have a DC link voltage over 800, which active line module absolutely could. And so it would just be showing either an overflow error or 800 volts. I'm not even sure what it would be. But so what we've done here is we have actually set up now a value here that is going to be coming back that is going to be the power factor for this system, which is pretty stinking cool. And that's just using that sign up para S function. Lots of stuff for it. What I'm going to end on, because we are a little over 2 hours. What I'm going to end on is a little bit of kind of talking about, go here, and then get all this stuff, because this active line module, I know I was kind of like nerding out about it. The first, like when I first started working as a Siemens distributor at Wesco, this was probably back in like, oh gosh, 2013, 2014, something like that. I gave a presentation to that customer, that steel mill customer that I was talking about the benefits of this active line module. Because the first time that I started actually looking at this thing, I'm like, this is more than just a rectifier. This is something that can be a real solution to power systems. I'm going to show you what I mean, because I'm going to show you a manual on the sketchpad. So this is the, if you could see it down there, the grid infeed manual. Okay, grid infeed. What? That sounds crazy, right? Like, why am I showing you this? This is a drive system. The thing about it is the active line module is such a powerful piece of technology. It can create a power grid. Remember, you have 6,000 amps at 480 that you could set up a system to provide 6,000 amps of 480 three-phase power, right? Because the thing about it, the way these things are sized is they're 100% both ways. So if it's 1400 if it's 1400 amps of DC link, then it's 1400 amps out. So if it's rated to draw and provide 500 kW of power, it can actually generate and put back onto the line 500 kW of power. And then all of a sudden, you're setting up this the power factor like we talked about too. Well, this was such a common setup that there is actually firmware for an active line module that has the grid infeed system. And what it does is it is 100% designed to take a generator, okay, a generator, and make a grid. And so like we were talking earlier about swinging our power factor of our device in order to be able to correct for stuff in a plant. Well, what if you had a waterfall, a mill or something, like a water wheel? Well, you would actually be able to put your water wheel on a motor, right? And guess what this is? A motor module. Right? This is an ALM. And then you can actually create a grid. Pretty cool, right? So the thought behind this would be, if for like large power systems, maybe you have a windmill over here, right? And so you're actually generating power using the active line module. And the way that you would do this is you would set this up to basically back down on the speed. And so you would create to where the windmill is turning at a certain speed, and your speed set point of your generator or of your motor module of your motor would be less than the speed set point of whatever it is. So, and then that would create this braking energy. And well, the braking energy would get converted back and put, in this case, onto the grid. The active line module is such a powerful device that it is actually, what's being shown here is it's actually has all of these grid codes and standards. So in Europe, I think it's IEEE, I can't remember. All right, so here's a directive to a public low voltage grid, VDEARN, blah, 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 all this stuff. That's Germany. Yeah, so all of these different things. I think there's like a UL listing or something for, yeah, here it is. So grid harmonics. So IEEE 519, and then in other places there's like UL. So this can actually supply power for a standard power grid system. And so here's a cool thing. So you've got a power grid where this is kind of set up over here as going out to other homes. Have an island grid, okay, just is a power grid. There's just no external connections, right? And well, if you're not doing an external connection, then you don't need a, like, necessarily to meet certain directives or anything. Just as long as you're, so like if you have a remote facility or a oil drilling derrick or something like out really remote, and you have like a little windmill, you could set it up using this. And I actually worked with some Siemens guys to set up this very thing using these systems. Last thing, and this is kind of what's called a microgrid. And here really unlocks the thing, and this is going to be the last thing to talk about on this stream, because I want to leave you with a little bit of creativity and a little bit of like thought to like what you can do with these type of systems. And honestly, the microgrids concept and system is stinking cool, because with really basically 2 pieces of hardware, or I guess three pieces of hardware, you can pretty much have a renewable energy system for remote installation. So, and 3-phase power. So I have a family farm in Alabama that we're looking to kind of update and get going. And one of the things that we're going to be doing is kind of creating this microgrid type of system for some of the stuff that we're going to be doing on that farm. Well, one of the things about this is it shows like different lines of power. So you have like a PV array going into to kind of create your grid, right? And so we would never be looking to do this, right? We would want an island grid, okay? And so, but the cool thing about it is if you have a big battery, and it doesn't even have to be like super energy efficient for this, but if you have a big battery, you would want your PV to be charging that battery, right? So you can kind of do away with this little line and have your solar cells just kind of, let me clear this. Just have your solar cells going into here with, obviously you would need a voltage. There would be a device here, and then at this point you're saying, okay, well you have to get that battery power out onto the grid somehow. Okay, cool. That's basically this. Well, here's the thing. What is this DC link? It's a DC voltage. That sounds kind of like a battery, right? What if there was a device that was made by Siemens, or anyone for real, that was a DC to DC converter to eliminate all of this and just plug right into here? Guess what? There's actually 2 different ways to do it. There is a software package for the S120 system that is a DC to DC converter, and it's a application or technology application, and it is a package that you can load into the CU to allow for this. There's also a device called the DCP, and it is a dedicated voltage to voltage current controlled DC to DC converter. But if we had this, then if we had a generator, say we had let's take this diesel generator and we physically connect it to this diesel motor, right? Like that. Well, we could have different couplings to have different ways to turn this generator, right? And again, we've already talked about how this is just a motor module. And then now this could be a motor module. So this entire system with multiple, say we have a diesel, say we have a CNG, so compressed natural gas. Wait a second. This right here can be renewable. You can use a biodigester. So, needless to say, these are some of these things. We can create natural gas from just regular digested products. And so you can create renewable natural gas from table scraps, from farm waste, anything that's organic. You break it down a certain way, it creates natural gas. And so we can cogen onto this generator, and all with a system that basically is two motor modules and an active line module. You're powering your farm. And you all coming from solar, cogen, and yeah. So these are some of the things that this technology, the active line module, really brings about. And it is a big solution to all of this stuff that is like, that kind of like, as an engineer, you're going to be facing kind of automation, renewable energy, like all of these things. And honestly, the active line module, if you really learn its capabilities, and the S120 platform in and of itself, is going to set you ahead and give you solutions to a lot of these things. So kind of, you're asking earlier, I think, Ali Reza, about trying to get some hardware to be able to do these. Well, hopefully this system is something that I will be able to implement over the course of the next year. I'm planning on doing this. And so while there might not be any hardware in my little Atlanta apartment, there's going to be some other hardware that we're definitely going to be doing some cool stuff with. And that's what I want to leave y'all with tonight. I say tonight, I guess it's definitely tonight for some of you guys. But what we're going to leave you with kind of that thought about just the active line module as part of kind of this, not just a piece of a drive system, but as a solution to a lot of problems. And that's one thing that I want to always kind of, in all of these things, is try to get you thinking about not just necessarily how to just solve this one little thing, how to use the Siemens infeed block, which hopefully all of those questions will be answered. I want to keep you curious. And so when you go out and sit there and say, hey, Jason talked about that. Jason talked about being able to do that with some piece of equipment. And for you to come back and keep that curiosity, keep that like wanting to get better and get improved, because that's going to be the biggest thing that you can do to increase your kind of, what's it called? Job security. Because one thing that no one can take from you is what you've learned. And as long as you're learning, you're always going to have some sort of something that you can go through and do. The biggest resource that is lacking today in all of these like industry at all is knowledge. And that is something that you can take to anyone. And honestly, like, hopefully this has been a little bit of insight into the active line module, what its capabilities are, how it can help you. And yeah, if maybe you've heard some of these conversations about power factor correction or reactive current and you're wanting a little bit more, ask comments, like drop your comment in the comments, just ask away. And yeah, until next time, I hope you have a great week and always keep learning. And yeah, it's been great. This topic is one of my favorite things to talk about because I nerd out on this piece of equipment. And kind of like I said, we're probably going to be seeing some pretty cool implementations of it in the future. Hopefully I'll be able to actually kind of bring that to you in a way that you get to participate in. But until next time, I hope that you keep learning and you have a great week. As always, I'm here for questions. If this has been helpful for you and you haven't subscribed, please subscribe to the channel. That's how we grow here. And hopefully you'll be able to join us live the next time if you weren't able to this time and you're watching this on demand. Either way about it, hope you have a great week. See ya.